Hello everyone. Today we will be practicing a few questions from the miscellaneous exercise. So first question says that decide among the following sets which sets are subsets of one another. So set A says that x is such that x belongs to R and x satisfies x square minus 8x plus 12 is equal to 0. So let's solve this equation. We have x square minus 8x plus 12 is equal to 0. Now this becomes x square minus 6x minus 2x plus 12 is equal to 0. Now we have x minus 6 into x minus 2 is equal to 0. So now we have two values of x and those are 2 and 6. So set A becomes curly bracket 2 comma 6. So now let's check which set is a subset of another set. So first of all, D is a subset of A, D is also a subset of B and D is also a subset of C. Correct? Now set A. Set A is a subset of B. Set A is also a subset of C. Okay. Now let's check set B. Set B. The elements of set B are a part of set C. So set B is also a subset of set C. Okay. I hope this is clear to everyone. Alright. Next question. Okay. Now in each of the following determine whether the statement is true or false. So we need to determine whether the statement is true or whether is it false. So if it is true, prove it. So if the statement is true, then give the proof. And if it is false, then give an example. And if it is false, then you need to give an example. So this clearly means that if the statement is true, then you need to give the proof. And if it is false, then you need to give a counter example to disprove the statement. So first part says that if x belongs to A and A belongs to B, then x belongs to B. Okay, so now let's take an example. So first of all, let A be equal to curly bracket 1 comma 2. Okay, so A is equal to curly bracket 1 comma 2. Now let's take x as 1. Okay, so clearly we can see that A belongs in set A. Now this means that x belongs in A. So this we have proven. Okay, now we need to take set B. So let's take set B as curly bracket 1 comma 2 comma 3 because we are given that A belongs in B. So B will be equal to curly bracket 1 comma 2 comma 3. So clearly does 1 belongs to curly bracket 1 comma 2 comma 3? No. 1 does not belong to this particular set. So clearly we can say that x belongs in A and x also belongs in B. But x does not belongs in set B. X does not belongs in B. So therefore this particular statement is absolutely false. So here is a counter example of the same. Okay. Moving on to next part. It says that A is a subset of B and B belongs to C, then A belongs to C. Okay. So we need to prove this as well. Okay. So let's take set A. Let A be equal to curly bracket 1 and B be equal to curly bracket 1 comma 2. Okay. So now here clearly A is a subset of B because the elements of A are a part of elements of B. Okay. Next, let's take C as curly bracket 1 comma 2 comma 3. So here we can see that why? Because B belongs in C. So C will be equal to curly bracket 1 comma 2 comma 3 curly bracket. Correct? Now let's check whether curly bracket 1 belongs to curly bracket 1 comma 2 comma 3. So does it belong? No, it doesn't belong. So clearly we can say that A does not belong to set C. So this particular statement is also false because clearly A is a subset of B and B belongs to C, but A does not belong to set C. Okay? Alright. Let's move on to next question. It says that A is a subset of B and B is a subset of C. Then A is a subset of C. Okay, so clearly the statement you can already prove that this statement is absolutely true. Let's take an example. Let's try it. Okay, so let's take A as 7 and B as 7 comma 8. Okay, because we firstly need that A is a subset of B. So here A is a subset of B. And let's take C. It is 7 comma 8 comma 9 for example. So clearly we can see that A is a subset of B and B is a subset of C. So according to this, A is also a subset of C. So basically this particular statement is absolutely right. Now we need to write the proof. Okay. So first of all, this is the given statement. First of all, this is given to us. This is given and this is to prove. Okay. Now we will write the proof. Now we'll write the proof. Okay. So first of all, we are given that A is a subset of B. We are given that A is a subset of B. That is, if X belongs in A, then X belongs in B. Correct? If an element X belongs in set A, then it is also a part of set B. Correct? And B is a subset of C. That is, if X belongs in B, then X also belongs in C. Now clearly using 1 and 2, using statement 1 and 2, we can clearly say that if if X belongs in A, then X belongs in B. This means that all the elements of A are a part of elements of C. Therefore, we can write that A is a subset of C. So this statement is absolutely true. Since this statement is absolutely true, so you need to write only the proof of this particular statement. Clear? Alright. Okay. Moving on to next question. Next question says that A is not a subset of B and B is not a subset of C. Then A is also not a subset of C. Okay. So let's check whether this statement is true or false. Okay. So let's take A as curly bracket 1. Okay. And let's take B as curly bracket 7 comma 8. So clearly we can say that A is not a subset of B. A is not a subset of B. Okay. Clearly A is not a subset of B. Now we'll take a set C. So let's take C as curly bracket 1 comma 2. Now here also we can see that B is also not a subset of C, correct? But the elements of A are a part of elements of C. So this clearly means that the elements of A belongs to the elements of C. So this means that curly bracket 1 will be a subset of curly bracket 1 comma 2. That is, A is a subset of C. So this particular statement will obviously be false. Clear? Okay. Okay. Next question says that X belongs to A and A is not a subset of B. Then X belongs to B. So we need to find that this particular statement is true or not. Okay. So let's take A as curly bracket 7 comma 8. Okay. And let X be equal to 7. Okay. Now clearly 7 belongs to curly bracket 7 comma 8. That is A. That is X belongs to A. Correct? Okay. Now let's take B as 1 comma 2. Okay. Now clearly we can here also see that 7 comma 8 is not a subset of curly bracket 1 comma 2. Okay. It is not a subset of 1 comma 2. That is, here also we can say that A is not a subset of B. But now let's check that whether X belongs to B or not. So X is equal to 7. Let's check 7 belongs to curly bracket 1 comma 2 or not. No, it does not belong to curly bracket 1 comma 2. So therefore we can say that X does not belong to set B. Hence this particular statement is obviously false. Okay, clear to everybody? Very nice. Okay, moving on to next question. The question says that if A is a subset of B and X does not belongs to B, then X does not belongs to A as well. So let's check that this statement is true or false. Okay, so let's check. So clearly it is given that A is a part of B. A is a part of B. We are already known. So let's take a set A. Set A is 1. Okay, And since A is a part of B, so B will be 1 comma 2. Okay, so now clearly we can see that A is a subset of B. Now let's take an element X which is not a part of set B. Okay, so let's take X as 7. So clearly 7 does not belongs to 1 comma 2. If 7 does not belongs to 1 comma 2, then 7 also does not belongs to curly bracket 1. So hence, if X does not belongs to B, then X does not even belongs to A. So this statement is true, sorry. This statement is true. Now we need to give the proof, okay? So this will be the statement that is given, and this is the statement that we need to prove. Okay, so let's check what will be the proof. Okay, let's write the proof now. Okay, so now it is given that A is a subset of B and X does not belongs to B. Correct? So now clearly we can say that if X does not belongs to B, then X will also not belongs to B. Why? Because A is a subset of B. So if an element is not a part of set B, then it won't be a part of set A as well. Clear? Okay. So this is the proof that you need to give. Hence, this statement is absolutely true. Clear? Okay. Very nice. Okay, moving on to next question. Next question says that let A, B, C be the set such that A union B is equal to A union C and A intersection B is equal to A intersection C. Now we need to show that B is equal to C. So whenever in this type of question, we need to show two things. If we need to show that B is equal to C, then we need to prove that B is a subset of C and C is also a subset of B. So we need to show that B is a part of C and C is a part of B. So only after proving these two statements, you can only say that B is equal to C. So mark it, this is a very, very important question. This is a very important question for your exams. Okay. So look at the proof carefully. It's really very important. Okay. So first of all, what we'll do is we'll firstly prove this statement that is B is a subset of C. Okay. So what we'll do, we let an element X which is a part of set B. So let X is belongs to B. If X belongs to B, then X also belongs to A union B. Right? If X belongs to B, then X also belongs to A union B. Now it is given that A union B is equal to A union C. Now we can write that X belongs to A union C. Correct? Now, what is the meaning of union? Union means or. Now we can write that X belongs to A or X belongs to C. Correct? Now we have two things. We have that if X belongs to B, then X belongs to A. Or if X belongs to B, then X belongs to C. So here we have these two conditions, condition 1 and condition 2. So first of all, we will take only the first condition. And first condition was that if X belongs to B, then X belongs to C. So according to that, we can write that taking X belongs to B and X belongs to A. What is the meaning of and in set? And means intersection. Now we can write that X belongs to A intersection B because X is a part of B and X is also a part of A. So according to question, A intersection B is equal to A intersection C. Now we can write it as X belongs to A intersection C. Now what is the meaning of intersection? Intersection means and. Now we can write that X belongs to A and X belongs to C. Okay. Now according to this, we can write X belongs to C. Now our initial point was that X belongs to B and now we have reached to X belongs to C. This particularly means that if X an element is a part of set B, then it is also part of set C. Now this clearly means that B is a subset of C. So this will be your statement 1. Clear? We have already proven this particular thing. Now let's check the another way around. Now we'll prove that C is a subset of B. Now we'll take an element Y which belongs to set C. Okay? If Y belongs to C, then Y also belongs to A union C. Now according to question, A union C is equal to A union B. Now Y belongs to A union B. Okay? Now again we have two things. Y belongs to A or Y belongs to B. Now here we have again two conditions. If Y belongs to C, then Y belongs to A, or if Y belongs to C, then Y belongs to B. So we'll take the first condition first, and that is if Y belongs to C, then Y also belongs to A. Now we'll write that taking Y belongs to C and Y belongs to A. Okay, so accordingly we can write that Y belongs to A intersection C. So according to the question, A intersection C is equal to A intersection B. Now we can write Y belongs to A intersection B. Now intersection means and, so we can write Y belongs to A and Y belongs to B. According to this, we can write Y belongs to B. Now, we started with Y belongs to C. Now we have reached to Y belongs to B. This means that if an element Y is a part of C, then it is also a part of B. Now, according to this, we can write that C is a subset of set B. Correct? Now, this is the second statement. So, we have proven this as well. So, using 1 and 2, we can obviously say that B is equal to C. Correct? This is again, I am telling you, this is a very important question for your exam. Make sure you have understood this particular solution very well. Okay? Alright. Moving on to another question. Okay. Show that the following four conditions are equivalent. Okay? Okay. So now this is basically a very logic-based question. Here we will take a universal set. First statement says that A is a subset of B. So this will be the Venn diagram. Okay, A is a subset of B. Okay, we need to show that all the given four conditions are equivalent. Okay, so A is a subset of B means A is a part of B. Okay, now second part says that A minus B is equal to 5. A minus B is equal to 5 means we need to remove all the elements of B which are a part of A. So if we remove all the elements of B which are a part of A, then we are not left with any of the elements. This obviously means that A minus B will be equal to 5. So clearly statement 1 will be equal to statement condition 2. Clear? Next. A union B is equal to B. Okay. If A minus B is equal to 5, this means that there is no extra element in A which is not a part of B. So A union B will obviously be equal to B only. Okay. So these three conditions are equal. Third condition, 1, 2, 3. Three conditions are equal. Next, let's see. A intersection B is equal to A. Okay. Clearly, if A union B is equal to B, this means that B is a bigger set and A is a smaller set. So all the elements of A are a part of B. There is no extra element in A which is not a part of B. So obviously A intersection B will be equal to A only. So this is also equal to condition number 4. So hence all these conditions are equivalent. Clear? Easy? Okay, next question. Show that if A is a subset of B, then C minus B is a subset of C minus A. So this is given to us and this is we need to prove. Okay, so let's see how we'll prove this. Okay, so first of all, we need to show that C minus B is a subset of C minus A. So we'll take an element X which belongs to C minus B. Now we know that C minus B will be equal to C intersection B complement because A minus B becomes A intersection B complement. Now this means that X belongs to C and X belongs to B complement. Now this means that if X belongs to B complement, then it obviously means that X will not belong to A. Sorry, it obviously means that X will not belong to set B. Okay, so here we can write that X does not belong to B because see, It is very simple. Like if we are given a set B, if X is here in B complement, then it is not here. So if X belongs to B complement, then X does not belongs to B. Clear? Now we are given that A is a subset of B, which means that A is a part of B. So if X does not belongs to B, then X will also not belong to set B. So here we have that X belongs to C and X does not belongs to A. Correct? Now again we can write that X belongs to C, and again if X does not belongs to A, then it is obviously a part of A complement. This means that X belongs to A complement. Okay, and means intersection. So we have that X belongs to C intersection A complement, and C intersection A complement becomes C minus A. So we have started that X belongs to C minus B, and now we have reached till X belongs to C minus A. So this means that C minus B is a subset of C minus A. Hence proved. Okay, so this is also an important question. Make sure you have understood it well. Okay. All right, moving on to next question. Show that for any sets A and B, this A is equal to A intersection B union A minus B. Okay, so let's prove it. We'll take the RHS. We'll take the RHS, which is A intersection B union A minus B. Okay, A intersection B union A minus B. So clearly we know that A minus B is A intersection B complement. Okay. Now we'll use distributive law here using distributive law. So distributive law says that A intersection B union C is equal to A intersection B union A intersection C. Okay. Now, according to this here, basically C is working as B complement. Okay. So, this becomes A intersection B union B complement. Now, let's check what will be B union B complement. Let's draw a Venn diagram. Here we have B and here we have B complement. So what will be B and what will be B union B complement? We will take B and we'll take B complement as well. So it is nothing but it becomes A intersection the universal set. Now what is A intersection universal set? What is the common between A and universal set? It is nothing but it is equal to A only. Okay. Hence proof this is your LHS side, and we have proven this particular statement. Okay. I have done this question. This question you will do on your own. Okay. This question you will do on your own. This is very much easier. This is also an easy question. Okay. Great. All right. Next question. Using properties of sets, show that A intersection B is equal to A. Okay. So let's prove this statement. So we'll take the LHS side, and LHS side says that A union A intersection B. Okay. So now we'll use the distributive law. So using distributive law, we have that A union B intersection C becomes A union B intersection A union C. Okay. Now this becomes A union A intersection A union B. Correct? Okay. Now A union A becomes A. Now A intersection A union B. Let's check using Venn diagram. So this is A and this is set B. So first of all we have A union B. A union B will be this portion, and next we have intersection A, and A will be this particular portion. Now what is the portion where A is come, where both black and blue color lines are coming, and is nothing but that is set A. So this becomes set A only. Okay. So now we have reached to RHS, hence proved. Okay. I have already done the first part. Again, this part you will do on your own. This is also a very easy question. Okay, let's move to next question. Okay, show that A intersection B is equal to A intersection C. Need not imply B equal to C. So here, just see it is written that need not imply. Need not imply means that we need to disprove this particular statement. Okay, so since it is given need not imply, so we will give an example. Okay, so let's take set A as 1 comma 2, and let's take set B as 2 comma 3, and let's take set C as 1 comma 4. Okay, now let's check what is A intersection B. A intersection B is 2, and let's check what is A intersection C. Okay, just a second. Let's check A intersection C. A intersection C is again 2. So clearly we can say that A intersection B is equal to A intersection C, which is equal to 2. But clearly B is not equal to C. Okay, so this is an example which you need to give for this question. Okay, all right. Next question. This is again a very, very important question. This is again a very important question for your examination. So let's read the question. Let A and B be sets. If A intersection X is equal to B intersection X is equal to 5, and X union B, X union A union X is equal to B union X. So this is the given statement. This is given. Now you need to show that A is equal to B. This is to prove. Okay, so this is to prove. Okay, so for this question, I'll give you two alternate methods. You can follow any of the method. Okay, so we'll prove this question using properties of sets. We'll do this question using properties of sets. Okay, so first of all, we have A union X is equal to B union X. Okay, so in the first case, we'll do A intersection on both the sides. A intersection on both the sides. So A intersection A union X becomes nothing but A only. Now, here we'll use distributive law. It becomes A intersection B union A intersection X. Clear? Okay. So here I'll write using distributive law. You need to write using distributive law. See, okay, or you also need to mention the law, okay? All right. Now it becomes A intersection B union. Now according to question, A intersection X is 5. So this becomes 5. Now A intersection B union 5 becomes A intersection B. Okay. Now we have reached that A is equal to A intersection B. Clear? Now let's check another form in this question only. Let's do. Now we know that we have A union X is equal to B union X. Now we'll do intersection with B on both the sides. Okay, this becomes B only. Now here we'll use distributive law. Using distributive law, we have that B intersection A union B intersection X. Okay, so according to question, B intersection X is equal to 5. So this becomes A intersection B union 5 is equal to B. So anything union with B becomes A intersection B is equal to B. So we have statement 1 and we have statement 2. So A is also A intersection B and B is also A intersection B. So clearly we can say that A is equal to B. Hence proved. Okay. I hope this method is clear to everybody. Okay, this proof is clear to everybody. Now let's check another way to do this question only. Okay. All right. We have this question now. This is given and we need to show that particular thing. Okay, so let's check how we'll do this. Okay, we can write A as A intersection A union X. Okay, according to question, A union X is equal to B union X. So this becomes A intersection B union X. Okay, now here we'll use distributive law. It becomes A intersection B union A intersection X. Okay, you will write here using distributive law. Okay, now according to question, A intersection X is equal to 5. Now this becomes A intersection B union 5. Now it is A intersection B. So A is equal to A intersection B. Now let's check for B. Now you know that you can write B as B intersection B union X. Now again, it becomes using, first of all, we have that according to question, B union X is equal to A union X. So it becomes A union X. Next, it becomes B intersection A union B intersection X. So this is nothing but this is using distributive law. I hope this is clear to everybody. Okay. Now, according to question, B union X is 5. Now it becomes B intersection A union 5. It becomes A intersection B only. So clearly A is also A intersection B and B is also A intersection B. Now we can use in 1 and 2, we can write that A is equal to B. Okay. I hope this is clear to everybody. Okay. Alright, let's move on to the last question of the miscellaneous exercise. And the question says that find sets A, B and C such that A intersection B, B intersection C and A intersection C are non-empty, whereas A intersection B intersection C is an empty set. Okay, let's take A, B and C. So let's take A as 1, 2. Let's take B as 2, 3. And let's take 3 as C as 1, 3. Okay. Now let's check A intersection B. A intersection B is 2. Next, B intersection C is 3 and A intersection C is 1. Okay, so clearly all of these sets are non-empty. Now let's check for A intersection B intersection C. So what is the common between all the three sets? There is no element which is common in all the three sets. So this becomes empty set, which is 5. Okay, so that's it with the miscellaneous exercise. Thank you so much for watching.